Welcome to Zoom in Data. In this session, we will discuss Databricks AutoML, which is a powerful tool for automating the machine learning workflow. AutoML simplifies and accelerates model development by automatically exploring feature transformations, selecting algorithms, tuning hyperparameters, and generating high-performing models. Understanding AutoML is crucial for interviews and real-world scenarios, as it demonstrates your ability to build reliable models quickly while maintaining reproducibility and interpretability. Key points covered in this subtopic include automated feature engineering, model selection, hyperparameter tuning, model interpretability, deployment, and integration with ML flow. Subscribe to Zoom in Data to continue structured learning of Databricks concepts. What is Databricks AutoML? Databricks AutoML is a feature in Databricks that automates the process of building machine learning models. It handles tasks such as feature engineering, model selection, and hyperparameter tuning automatically. AutoML reduces the manual effort required for experimenting with multiple models and configurations. It ensures reproducibility by logging all steps, transformations, and metrics automatically for each run. Why is AutoML important in ML projects? AutoML accelerates model development, allowing teams to focus on business problems rather than manual experimentation. It reduces the risk of human errors in feature selection, algorithm choice, or parameter tuning. Teams can quickly benchmark multiple algorithms to select the best performing model. AutoML improves collaboration by producing reproducible models that can be audited and deployed confidently. How does Databricks AutoML automate feature engineering? AutoML automatically generates new features and transformations from raw data. It identifies categorical, numeric, and text features and applies appropriate encoding or scaling. Feature selection is optimized to remove irrelevant or redundant features. This automation ensures that models have high-quality input data without extensive manual preprocessing. How does AutoML perform model selection? AutoML evaluates multiple algorithms suitable for the dataset and problem type. It runs experiments across different models and compares their performance metrics. The system selects the best performing model based on accuracy, F1 score, RMSE, or other relevant metrics. Automated model selection saves time and ensures that the chosen model is robust and suitable for deployment. How does AutoML handle hyperparameter tuning? AutoML uses techniques like grid search or Bayesian optimization to identify optimal hyperparameters. It tests multiple combinations of parameters efficiently without manual intervention. Hyperparameter tuning ensures that models achieve the highest possible performance. This process reduces trial and error work and guarantees consistent and reproducible results. How does AutoML integrate with ML flow? AutoML logs all experiments, models, parameters, and metrics automatically into ML flow. This ensures traceability of every model, including feature transformations and hyperparameter settings. Teams can compare multiple runs and select models confidently for deployment. ML flow integration also enables versioning and governance for production-ready ML workflows. What types of problems can AutoML solve? AutoML supports regression, classification, and time series forecasting tasks. It is suitable for both structured and tabular datasets commonly used in business applications. Teams can apply AutoML for predictive modeling, churn analysis, or demand forecasting. This flexibility allows faster experimentation and rapid deployment of solutions for real-world problems. How does AutoML improve model interpretability? AutoML generates explanations for feature importance in the final model. Visualization tools highlight which features have the most impact on predictions. Interpretability helps stakeholders understand and trust model outcomes. This is especially important in regulated industries or when models affect critical decisions. How does AutoML ensure reproducibility? All transformations, feature engineering steps, and model parameters are logged systematically. Each run is versioned in MLflow to allow replication of experiments. Reproducibility ensures consistent model performance when rerunning or deploying models. Teams can confidently audit experiments and validate models for compliance. Can AutoML handle large datasets? AutoML leverages Databricks clusters for distributed computation, ensuring scalability. It can process millions of rows efficiently without manual optimization. Distributed execution reduces training time while maintaining model quality. This makes AutoML suitable for enterprise-scale ML applications. How does AutoML support production deployment? AutoML produces models that are ready for deployment in production environments. Models can be registered in MLflow's model registry with proper versioning and stage transitions. Feature transformations are tracked to prevent training serving skew. This ensures reliability and stability when deploying models for business-critical applications. How does AutoML help beginners and non-experts? AutoML abstracts the complexity of model development, making ML accessible to non-experts. It automatically handles pre-processing, model selection, and parameter tuning. Users can focus on business logic and interpretation rather than technical implementation. This democratization of ML accelerates adoption across teams without compromising quality. How does AutoML improve team productivity? Teams save time by automating repetitive and labor-intensive tasks. Collaboration is enhanced as models and experiments are logged and shared centrally. AutoML provides clear visualizations and reports for decision-making. Productivity increases because engineers can focus on refining models and solving complex problems. What are some limitations of AutoML? AutoML may not capture domain-specific feature engineering as well as manual approaches. For extremely large feature spaces, it might require fine-tuning to avoid long computation times. Complex models like deep learning architectures may need additional customization. Understanding these limitations helps teams decide when manual intervention is necessary. How does AutoML handle missing data? AutoML detects missing values and applies appropriate imputation techniques automatically. It ensures that model training is not affected by incomplete datasets. Data pre-processing steps are logged for reproducibility. Proper handling of missing data improves model accuracy and reliability. Can AutoML handle categorical features? Yes. AutoML identifies categorical variables and applies suitable encoding techniques like one-hot or ordinal encoding. It ensures that models can learn from categorical data without manual intervention. Encodings are logged and versioned for consistent reproducibility. Correct handling of categorical data improves model performance and interpretability. How does AutoML support model evaluation? AutoML evaluates models using multiple metrics relevant to the problem type. It generates visualizations to compare model performance across runs. Evaluation results are logged for reproducibility and auditing. Accurate evaluation helps teams select the best model for deployment. Can AutoML be combined with custom models? Yes. AutoML allows integration with custom models or external libraries for experimentation. Teams can fine-tune or replace AutoML-generated models with specialized implementations. Customization ensures flexibility for complex business requirements. Combining AutoML with custom models maintains reproducibility and logging through ML flow. How does AutoML help in rapid prototyping? AutoML automates feature selection, model training, and hyperparameter tuning. Teams can quickly generate baseline models for proof-of-concept projects. Rapid prototyping accelerates decision-making and business impact. AutoML ensures that these prototypes are reproducible and ready for scaling. How does AutoML integrate with Delta Lake? AutoML can read input datasets stored in Delta Lake, supporting batch and streaming data. Delta Lake ensures ACID compliance and data reliability during preprocessing. Feature transformations and training datasets are versioned consistently. Integration guarantees reproducible pipelines for enterprise-scale ML workflows. How does AutoML optimize hyperparameters efficiently? AutoML uses automated search strategies like Bayesian optimization or grid search. It tests multiple parameter combinations systematically to find optimal settings. Logging ensures that the best parameters are tracked for reproducibility. Efficient optimization reduces training time and increases model performance. How does AutoML handle time series data? AutoML automatically detects temporal features and applies appropriate transformations. It can split datasets using rolling windows for proper training and testing. Temporal consistency ensures accurate predictions for future data points. This allows rapid deployment of reliable forecasting models in production. How does AutoML support explainable AI? AutoML provides insights into feature importance for model predictions. Visualizations and reports help stakeholders understand the impact of each feature. Explainability increases trust in model outputs, especially in regulated industries. It ensures that models are transparent and interpretable without manual effort. How does AutoML improve ML lifecycle management? AutoML automatically tracks experiments, transformations, metrics, and models. Integration with ML flow ensures end-to-end lifecycle management from experimentation to deployment. Teams can version, audit, and reproduce experiments efficiently. Proper lifecycle management reduces errors and accelerates model delivery to production. Why should Databricks professionals master AutoML? Mastering AutoML allows teams to build high-quality ML models faster and efficiently. It ensures reproducibility, traceability, and governance of ML workflows. Professionals can focus on business impact while AutoML handles repetitive tasks. Expertise in AutoML enhances credibility, accelerates project delivery, and supports enterprise-scale ML deployment. If you found this video helpful, like, share, subscribe. More Databricks interview and tutorial videos are coming soon. Stay connected and keep learning with Zoom in Data.